Hello and welcome to my video, lesson 1.1 on function operations or function operators. So we can do operations on functions just like we can on numbers or variables. And this is very important. We're just looking at the basic operators, adding, subtracting, multiplying, and dividing. It's almost like transformations, but it's not quite the same thing. We're composing functions, we're putting functions together by adding them together, subtracting them, multiplying, dividing. And then in the next video, we look at functions within a function, functions of other functions. Okay, so these are the different notations that you need to be able to recognize for adding, subtracting, multiplying, and dividing. Notice that there's like two versions of each of these. So there's kind of this version, and then there's kind of this version. You need to recognize both versions when it's written down on a test or whatever. Okay, so we're going to use the following graph in order to add two functions together. So what we're going to do first is pick a couple nice points, quote unquote, on the graph in order to add these two. So we're going to pick 4 or 5 nice points. Let's see if there's any that line up. Maybe here. That looks like a nice one. So I'm going to call that x equals 0. Yeah, 2, 4, 6. I'm going to pick those ones there. So you can hopefully see those different points. We could certainly go to 8. We could go all the way to 10 for sure as well if we wanted to. But there you have it. So if we look, I did also try to color coordinate it. So the blue line is the f of x function. And you can see that my first value is at -8. My next value is at -5, -2, 1, 4, and 7. And for the g of x function, that's the green one, we start at -1, 0, 1, 2, 3, 4. And so when we put those two things together, we add them, we get -9, -5, -1, 3, 7, 11. So when we plug this all in, our first point would be down here at -9. Then it'd be here. Then it would be here. Then it would be here. And this one's what, at 7? Yeah, 7. And this last one would be at 11. So it's kind of slightly off screen there. But you can kind of see that this purple line is roughly what that looks like. Okay, and what's kind of cool about this is when we look at the actual functions themselves, hopefully you can kind of see that f of x is, if we think about it as y equals mx plus b, it's -8, that's the b value. It's growing, so it's positive. It's going up by 3, over to the right by 2, so 3 over 2. The g of x function is 1 over 2. It's still growing, but it's got a -1 like that. And when we add those together, well, what we're actually doing is we're going like this. And so our new function is -9. And you can see we add the two slopes here. So we're just literally adding these values together. And so this is going to be 4 over 2 or just 2x. And that matches with what our purple line actually is. And this is kind of cool because we can also graph this to check. So if we wanted to, we're not going to do this for everyone, but 3 over 2x minus 8. I'll use the same colors actually. 1 over 2x minus 1. And then here, 2x minus 9. Or, and this is the kind of other side. Well, let's just graph that first. So you'll notice that that matches with what I drew on the graph. But we could go to the red one and we can use something called vars, which stands for variables. It's right over here on the calculator, right underneath the arrow keys. So we're going to press vars and we're going to go y vars function y1 plus y vars y2. And so now what we're saying is that red one is going to be y1 plus y2. If we graph that, we're going to notice that, oh, that's a problem. I made a mistake. It shouldn't be y2 because I used the y5. Y2 is graphing itself. So we're going to delete that. It's going to be y5 because the y1 is the blue one, y5 is the green one. So that's what I wanted to add together. And you can see that the red one and pink one or purple, whatever, overlap completely. And you can see that again in the table of values as well. You can also look at the table of values and take the y1 and the y5 and add those two together. So the -8, -1 gives us the 9 that we have for the pink and red ones. Okay, so a graphing calculator could be helpful here for some questions, depending on if you have an equation. Let's take a look at another one. Let's look at subtracting. So again, we're going to pick some nice points. Actually, we're going to pick the same points as we did before, which I believe was 4, 6, 8, 10. So the blue one is going to have -8, -5. Let's just make sure we actually have this. -2. Not negative. This is positive. +1. +4, +7. And then the green one. Ooh, looks like our green has shifted a little bit, but it was supposed to be right on the line here. So just trust me that it's supposed to be on that line. So it's going to be -1, 0, 1, 2, 3, 4. And when we subtract them, remember we're subtracting in this order. So it's -8 minus -1. So it's actually -7. This is -5 minus 0, so it's -5. -2 minus 1, so it's -3. 1 minus 2, so it's -1. 4 minus 3, so it's 1. 7 minus 4, so it's 3. So if we plot all those points, we get -7, -5, -3, -1, 1, and 3. And you can see again that we've created this straight line there for the purple one. Okay, notice, this is a common mistake, just notice that f minus g is not the same as g minus f. For subtraction, order matters. All right, let's take a look at another one here. Okay, so we have this graph here, and what it's now asking us to do is graph for the different values, or just find the different values. So f of 0 plus g of 0. Well, all we have to do is find the different values for that situation. Oh, and f is the blue one, in case that matters for some of these questions. So in this case, this would be 2 plus 1 equals 3. I recommend you pause the video now and see if you can get the same results that I do for the next couple. All right, we're doing f minus g of 3. So this is going to be at 3. F is 1 minus g, which is 2. So it is -1. Okay, the next one's at 8. So here and here. And we are doing G first in this case. So it's going to be 3 minus 6. So it is -3. Okay, G plus F of -2. So at -2, we have this value. Whoops. We have this value here. And what value? So that's 4. But what value do we have for the G function? We don't have a value. It does not exist. So if we have a situation where it does not exist, we're just going to say the whole answer does not exist. We can't add or subtract something and have a result if half of that thing does not exist. Okay, if we're stating the domain of the different situations, well, whenever we add or subtract for all of these, you're going to have this situation over here on this side of the graph. So x has to be bigger than -1. Because if it's less than -1, one of the two functions does not exist. And so that is a restriction on the domain over there. Okay, so let's take a look at some actual algebraic expressions. So instead of just looking at graphs, what if we did this with algebra? Well, we can do f minus g of x. And so here you can see the two different functions. And what we're going to do is go f, which is x squared minus 2x plus 1, minus g, which is x minus 1. And then we can combine those together to get a final result. Just keeping in mind that this negative goes into the brackets in both places. So it's going to be plus there, it's going to be a minus there, so it's going to be -3x plus 2. And that's our new function. Fun fact here, if you wanted, you could also PSA this. For some questions that might be helpful. I don't think that's helpful in this question, but you could. All right, let's take a look at multiplying. So here we have some examples where we're going to multiply two functions. So it's f times g. We're going to pick some beautiful, nice values that if we can, and then multiply those. So here's a nice value. This looks like a nice value. This looks like a nice value. This looks like a nice value. Let's just stick with those ones. So we're going to have -4, -2, -1, and +1. Yeah, let's stick with those results. For the f of x function, which is the blue one, we're going to have 0. We're going to have 1. We're going to have 1.5, which isn't ideal. And we're going to have 2.5, which is not ideal either. Then for the g of x function, let's look at those different values. So this is 4. This is -2, -2, and 4. So when we multiply those results, 0 times 4 is 0. Multiply those, we get -2. Multiply those, we get -3. Multiply those, we get 10. Right? Yeah. So if we were to graph this result after all this work of finding these different values, we'd have -4 at 0, -2 at -2, -1 at -3, and then 1 at +10. And hopefully you can see that this is kind of a weird graph, and that's kind of something like this, right? I don't know exactly how this is going to look, but it's going to look a little bit odd. And that's kind of normal. So again, if we go ahead and, oh, no, we can't see this one because we don't have the graphs. But whatever, it's going to look kind of funky like this. We only know those dots. Okay, dividing, same sort of process. Just again, like subtraction, there is a order that matters here. So we're going to pick a couple points that match nicely. So here's a point. Here's a point. Here's a point. Those are probably the main points, those three. So we're going to say at -3, -2, and at 1. There are other points that look like they might be close, but I don't think anything else exactly lines up with the corner. So the blue one is 9, 7, and 1. The red one is -2, -1, and 0. Okay, so 9 over -2, and we're just going to get like a -4.5. There's nothing more to it. 7 over -1, it's just a -7. Again, nothing more to it. There's nothing we can do about that. So it's those two dots. But at 1 over 0, you're dividing by 0. So it does not exist. And this is a big deal here. So dividing by 0 means it does not exist. And some functions are going to have this effect take place. All right, one last question to try. What is the new function of f over g of x? If f of x equals x squared minus 2x plus 1, g of x is x minus 1. What is its domain? Well, if we're dividing these two, we can just write that down and look at what actually happens here. When you divide those two, you can hopefully see that the top one is like this, and the bottom one is like this. And so you can see that these cancel. But before you can cancel it, you have to keep in mind that this denominator cannot equal 0. So x cannot equal +1. This is a new restriction on that domain because of that dividing by 0 rule. So we say that it is x minus 1 where x cannot equal 0. I hope this video helped you better understand composite functions, especially adding, subtracting, multiplying, and dividing. I hope the video helped, and good luck.